All right, we are live. Hello, everyone, and welcome to eDrilling live webinar presentation. Thank you all very much for tuning in and joining us today. Hopefully, you should be able to both hear and see us quite clearly. So I can start by introducing myself. My name is Alina Sundalskleiv, and I will be taking you through the next 30 minutes of this eDrilling webinar presentation on drilling advisory system and drilling parameter optimization in real time. I'm also joined by a colleague of mine who I shall introduce to you very shortly. But before we move on, just some general information about this webinar. So if you are new to our webinars, or if you're new to eDrilling in general, we are a software company that bring our unique technologies to the drilling world. And if you tuned in to our monthly webinars before or joined us before, thank you very much for your continued support. As mentioned, I have my colleague here, Christian Solem, joining me today. He will be presenting on behalf of the company on the subject drilling advisory system. And you might have seen Christian before. He is our VP in product strategy and management, and his background is in project management, as well as drilling and wells and software solutions. So we are very much excited to have you here, Christian. We are also very excited to introduce this project and this subject to our viewers, as this is one of the first. Let me give just a quick overview of the agenda for this webinar. It's a fairly short webinar. We have around 30 minutes to go through the presentation. We try to keep it short and crisp. However, we have dedicated around 5 to 10 minutes at the end of this presentation for a Q&A session. So as you might have noticed, we have a public chat to your right. Feel free to use that, but you can also message me privately by clicking on the icon, and I will provide you with the icon during Christian's presentation. So I recommend that you message me privately for any questions that you would have during the presentation or during the Q&A session, and we will make sure to try to get time to address all of them. So introducing the subject, Christian will start introducing some of the market challenges that we are experiencing today, and also how addressing these challenges has created the fundamentals of the technology that we are providing. And he's also going to do a deep dive into the benefits of utilizing AI technologies for old rigs that are currently using legacy systems, by then taking a closer look at real-time drilling parameter optimization. So we have short time. I think that is enough for the introductions. Without further ado, Christian, the word is yours.
Thank you, Alina. So as mentioned, we'll start off with the market challenges, both on what kind of issues that has formed the development of the real-time drilling parameter optimization system that we have, and also what you should think about when considering doing upgrades to a legacy system, let's say. So there are, of course, many needs and challenges with respect to drilling a well. So we've listed here 3 major issues when it comes to this particular topic, which is then having real-time drilling advisory. So the first point being rigs with legacy drilling control systems. Secondly, back-end office support is required in remote operating centers and also throughout for operating and handling these data models and doing this advisory. And then third, we have well control incidents and sidetracks, which are always a challenge. So I will dive a bit more deeply into each of these points, starting with legacy systems. So usually when you're considering to upgrade your drilling control system to receive any or have any kind of automation and real-time advisory, then it means an upgrade of the drilling control system and also equipment. And after talking to various operators, they have reported that the average cost of upgrading this will be about $20 million. So it's quite a substantial amount of money. And also this will heavily affect the carbon footprint. And also it is demanding work, both on the organization and for the people involved. Secondly, there is a lot of subject matter experts involved in looking at real-time advisory, updating models, keeping track of the data. So a lot of the time is spent on looking at screens and copying and pasting information, which is in all respect an insufficient or inefficient use of resources, where those that have domain knowledge and domain expertise could be utilized better for optimizing the well and plants and so on. So the third one is then the well control events and sidetracks. There are, of course, a lot of parameters that are involved in how the well responds to what we are doing to it. And some of them are in encountering loss situations, having high torque in the well and on the equipment, pressure limits not being kept, failure situations, and so on. So going into this topic on how to address all of them, the next point will then be to look at the background technology before we dive into how the solution is and how you can utilize technology for having then real-time advisory. So starting with the models. So if you are going to have then real-time advisory and drilling parameter optimization, you need to have models in the background. In this case, with dynamic hydraulic and temperature models and torque and drag models that can model how the well should behave. So here we have things like multi-phase flow, the pressures, temperatures, weight and bit, torque, and so on. And the next point then being that when you have these models that are giving you values of what the values you should expect to see in your well, you have the modeled behavior. So you make a prediction, and then you have the predicted behavior of the well. We then also take the actual system, which means the real-time data from the platform or the rig. Then you have an observation and an observed behavior. And then, and only then, can you do a comparison between these to look at the minimized variance between the predicted and the observed behavior to figure out if something is out of bounds, if there is a discrepancy. So if you're only looking at the actual system and seeing that the trends are changing, you don't really know if that is supposed to behave like that. But when you have really good models also, that makes it possible. And this is the background then for a digital twin technology, where we have the anatomy of the physical well with the real-time data with well depth, bit depth, the RPs, hook load, weight and bit, and so on. You have the calculated models in the digital twin, which is then the digital representation of your well and how the well should behave. And then to compare this, we have a layer of artificial intelligence and machine learning algorithms that compares then the real-time values versus what is the model values from our dynamic models, and it sees if there is any discrepancy. And when it does that, we can have diagnostics of the well, predictive analytics, we can do forecasting, and what-if simulations. So the system requirements is then three-part. We need then the real-time drilling data provided by operators or contract system, which is standard mud logging data, survey data, and mud properties. And the second you need is field input data. You need to have pressure profiles, pore, fracture, collapse pressure, formation temperature, 3D layers for visualization, so you know where your boundaries are and where you should keep your ECD. And the third is then the operation team input data. So when you are doing a certain operation, you select which string you're going to use, which BAJ, and then you can start monitoring and actually have the real-time optimized parameters. So that is all the background technology of the solutions that we have and that we are developing. So the next step is then to have a look at the solution itself. So here I'm going to go through 3 cases that we have where our system has been used for 3D visualization while drilling, and where we have then run analysis and so on to get optimized results. And I'm also going to show you our latest development, where we are developing a new user interface and also developing a system for making this even better. So before we start off by actually drilling and then monitoring, there needs to be a way to have a simple configuration to set up the well and the models. So we have kept this in mind in development so that the data is easily accessible and can be put into the model, so that the end user then only has to select the string and which operations that are going to be undertaken. The next step is to have all of this available for the driller, so you can have it on the screen in the drilling cabin, so that they can be aware of what parameters that they need to have, and also to look at the 3D visualization during operation. So case 1 is where we can see here the 3D visualization of the wellbore. This is quite a bit zoomed out. We've done that to highlight a lot of the elements that can be put in. Some of them are the risks down in the well. And you can also have measurements of the ECD at certain points in the well, so it can tell if you are at the correct value or if you are higher or lower than what you should be. So for this particular case, they used it for having a trip risk log, ECD management, and while liner and casing running, and also to track stringers and shale areas in the well. So we had automated roadmap plot of the friction and also forecast simulation for surge and swab in certain sections. So the next case was while running in hole with the 13.5/8" casing, where we had tripping speed recommendation, got diagnostics of poor hole cleaning and also high friction. We detected overpull and then came with suggestions on how to optimize this. And here you can see in also the 3D visualization and the roadmap plot of the frictions. So the last case was also used the trip risk logs and stringers tracking versus the reamer and the BAJ. So you can follow in real time these BAJ elements going through the well through certain tight spots, so you can have a clear overview of where you are. In addition, we had ECD management and then optimal run-in hole and pulling out of hole speeds and friction mapping, which all of this resulted in visual risk awareness. Operational risks were addressed, and also there was optimization of the performance. So now going into more of the new development that we are currently doing. So we are looking into updating the UI, as I've said, to make it even easier to prepare and also use it during operations. So first we need to connect to a real-time source, be it through OPC UA or WITSML, where you select then the well and the wellbore that you are in. Next step is to choose the run that you're going to do, which BAJ or casing liner or tieback. And with this being a new development, what we have put up here are sketches that we are of how the visualization should look like. So it might be that in the end we are going to have it slightly different than what we are seeing right here, but the principles will be the same. So the next step is to, or once you have then, or your casing hole sizes, you have the wellbore geometry with the setting depth, here both in TVD and MD. You select the fluid that you're going to use for the section, which is also then prepared on beforehand, and of course coming in real time from the WITSML data. And also you have the risks which you can put in, so it will be easy to look at while you are in the operation to see where do we need to be careful. And the thing with this being a software is that we have, of course, made it so that everything can be put in manually. But if you in the company have a repository or a database where you have all of this data from before, maybe a lessons learned database or something similar, then of course it is the possibility to connect this together to streamline the operations through open APIs. But of course, this needs to be then configured in the case that is necessary and relevant. So with the input being prepared, this is what the operator screen will be like. So we have made one in the light mode, and then we also have one in dark mode, which we will probably start by creating this one. So you can see here that this is then the drilling advisor. And if we start off with the first tab here, we can see that this is a tab of the trends, and it is backward looking 15 minutes and also forward looking into the next 15 minutes. So here we monitor the values for flow and rotation per minute and rate of penetration. And we have here static values for what is actually written in the drilling operational procedure. So what this will do is then it will tell you which level you're currently on, which flow you're having, which RPM, which ROP, and it will give you then a suggestion for what you should increase or decrease or hold these levels at to have an optimal wellbore delivery, to have it stable and also optimize performance. And this is done by running in real time what if and forecasted simulations. So then as the driller, they can see where we're at and see, okay, here we need to increase, and then try to go up to the level that is suggested. And on the right side here, we have simultaneously diagnostics that is being given. Because here we have the mentioned machine learning and artificial intelligence algorithms that are looking at the real-time values versus the modeled ones to see, is there anything happening in the well now? So in this mock-up, we have fluctuating SPP and standby pressure and torque, which is given. And it could also be saying that further down the line, you're going to go into a poor hole cleaning situation where you might have a pack-off, and then, for example, it is showing here that the flow should be increased for, let's say, hole cleaning purposes. And these diagnostics can then also be seen here in the trend, so you can see what happened previously and also what is going to happen in the future. Then we have a schematic of the well, where you can choose to have a look at the whole well, or as here, where I just selected the latest casing shoe, where you can also have a look at the diagnostics and see where they occurred. So the next operator screen is then the trip advisor. So for tripping, there might be other parameters that we want to look at. So here we have the speed, where it gives the recommendation for where you should go. We can look at the ECD at certain points in the well, for example, at the shoe, or if you have weak formations or anything that can be put in. So we can always monitor and make sure that we are within the boundaries. In addition, we have the hook load that you can look at while tripping, and also the 3D visualization. So you can follow the string and follow the BAJ as you are actually performing it. So to summarize the very quick introduction to the Drilling Advisor and the real-time drilling parameter optimization system, the key points that I would like to highlight is that this can actually be installed on old platforms and rigs. So to have this degree of optimization or getting real-time optimal parameters, there is actually not the need to upgrade it. It can actually be done, or it is being made to be used for even these old rigs and platforms. And that enables you to not only reduce the carbon footprint, but also save roughly $20 million per rig or platform. In addition, it lessens the need for back office support with respect to operating, using these models, updating and monitoring, because we are working with having auto calibration and an automated configuration as well, so you can better utilize your resources. And last but not least, it gives optimal drilling parameters in real time so that you can avoid wellbore incidents and also improve your well performance. So with that, we've gone through everything that we wanted to say today. So hopefully there has come in some questions from the audience.
Thank you so much, Christian, for your presentation on Drilling Advisory System. Yes, I have received a couple of questions throughout your presentation in the private chat. Again, it is not too late to ask any questions regarding this subject or any subject in general regarding the e-drilling webinar. So I'm just going to take it from the top on the private messaging. I think one interesting question here that we can clarify right away, a question for you, Christian. An attendee is asking about, you're talking about one system to be in place and one already developed. When will the product be ready for market?
Yeah, so that's of course a very important question. So the one that we have in place already is being utilized by many operators as we speak and has been in place for many years. And the development that we are currently doing, we're doing with several partners, both operators and rig contractors and rig owners. So the first product will be available in this autumn for the partners, but then it will be open or readily available for the general audience after, or let's say Q1 next year. So first quarter next year.
First quarter next year. Okay, thank you very much, Christian. Another question here is, can advisory software solution be used at any type of well, or is it designed for a specific type? So maybe I can help clarify that. The very clear and short answer to that is no, it's not designed for a specific well, and yes, it can be used at any type of well. So just to get a better understanding, I'll give you some background on the technology being used here. So by using the advisory software solution, it's illustrating your specific well in a digital twin perspective. So, and also Christian touched on this subject earlier, while looking at your well in a digital twin perspective, it is a realistic and digital representation of the actual well that you are drilling, which is constantly being updated with real-time data. And this also goes for our other software solutions, whether it's in the preparation phase for drilling a well, or if it's a designing or a configuration of a well, you're also viewing your well in a digital twin and using it as a visual roadmap. And I can give an example. Often our customers, they use our software for particular complex wells. As the drillers, they rely fully on being able to see any risks or alerts that are ahead by the software providing them with diagnostics, forecasting, what-if analysis, and so on, that Christian also mentioned earlier. And this is helping them making better decisions to avoid any incidents, such as hazardous incidents, but also providing them with best practice actions. So the same technology that we've been using for well preparation and well design is also based on the same principles applied to the drilling advisory system as well. So to summarize that answer, the answer to that question is yes. The software solution can be used at any type of well. So I hope that clarifies your question. Another question coming in for an attendee here is, you mentioned that using AI and machine learning algorithms, the drilling solution can detect diagnostics ahead of time. How early can the software detect these diagnostics?
So that's one for me, I guess.
Yes, that's one for you, Christian.
Yeah. So we've seen this is of course varying from case to case. Every well is different, but of course we often see the same challenges as well. So it has been detected at various points before the situation actually happened. So not long ago, we had a message coming in that you need to do something with well, it's a poor hole cleaning condition, so something should be done, but it wasn't acted upon. So we came into then a situation 3 or 4 hours down the road. So that is one case, but we've also seen it previously that it can give a notification many hours before. So it will vary, but usually there are time to react to it.
Okay.
And it is when not reacting that it goes wrong.
Right. Thank you for clarifying that. Also, still looking at the private messages here, what parameters are to be measured on the rig to feed the software, and what quality requirements are there for the measurements?
Yeah, so the parameters to be sent to us is what is usually in the WITS-ML. So you have the torque, the RPM, the ROP, weight on bit, the flow, and so on. And the quality is, if I'm not mistaken, it should be updated more frequently than every 5 seconds. I think that's what we're saying as our limit. But of course, if you are interested in having a look at this, then please require more information. That it might vary a bit more than this.
Okay, thank you. Christian, I also see we are running out of time, so I'll pick up another question. And for those questions that were not addressed, we will make sure to reach out to you individually after this webinar. So the last question for today is, what do you recommend being the first initiative for companies evaluating an upgrade of their legacy systems?
Yeah, so if you are looking into then the possibilities to upgrading your old rigs and platforms with new equipment for this specific purpose, then the first thing I would do is to figure out, okay, what is it that we want to achieve? So if it is done to achieve that you have optimal parameters to act on, to then have better and safer well placements, then there actually might not need to be a case for doing it, because you can save all of that cost and use existing systems to have it in the same or achieve the same results as you want. So that is the first thing that I would look into. If you can achieve more with less, it saves you time and cost and improves the operations. So why not?
Right, thank you. That's a good recommendation as well. I see we have to wrap up. We are out of time. Again, apologies if we weren't able to address your questions, but we will reach out to you after this webinar. You will also receive a link to the recording of the webinar after the broadcast ends, so feel free to watch that as well. So for any general questions or inquiries, please reach out to us at info@edrilling.no. Thank you very much, Christian, for presenting. Thank you for everyone who registered for today's webinar. Have a nice day, everyone.
Thank you, Elina. Thank you, everyone.
Thank you. Bye-bye.